Go is full of errors. So much so that some would even say Go is an error in itself. Now, as gophers, you're going to have to use errors and deal with them in your programs using things like if error does not equal nil, if error does not equal nil, if error does not equal nil, does not equal nil. You get the point. So let's talk about errors. Let's talk about all the things errors, wrapping, custom errors, all of these things. Let's talk about it and see what we can do. First, let's talk about error handling in the main function. The main function in Go is a function that is the entry point for your application. This is where execution begins. In here, I'm doing a few things. I'm creating a file, and creating a file returns a pointer to a file and an error. I'm deferring the close of that file, so that close method returns an error as well. And I'm writing a string into that file, and that returns the number of bytes written and an error. I'm also printing out how many bytes I wrote, but that doesn't return any error. Like, that's fine. I mean, it technically does, actually. If you look at the method signature, this does return an error, but it's generally convention to ignore print errors for the most part. We'll talk about this defer error handling here in the future, but let's ignore this for now. So really, I have two places that I need to handle errors. I need to handle an error on the create and an error on the write string. And in Go, the way you handle errors is by checking if they're non-nil, right? A non-nil error means that you received an error and you should do something about it. But I'm all the way up here in main, right? So there is no one calling me. There is no like passing this error up the call stack and letting my caller handle it. I'm the end of the line. So I need to deal with this error. Now, there's a few things you can do. One is you can just panic, right? You can just say, screw it. I'm writing some like prototyping code. I don't want to deal with this right now. I'm going to panic. Everything will be fine. And this is valid, right? I do this when I'm writing like very trivial code that's kind of throwaway code. You can do this. This is fine. Alternatively, you can do something better. You can like print the error. So and then os dot, exit 1 or something. And you can do this. And I'll change that down here. And every time that you want to handle an error, you can like print it and exit 1 and everyone's happy. This kind of gets really old really quick. Imagine if I was calling like 10 different functions or methods that return errors. I have to do this for every single one of them. I have to print the error and handle it or panic or whatever. That's kind of miserable. It's very easy to just instead say, I just want to return this error, right? I don't actually want to handle it. I want to return it to my caller. But I'm in main, so I don't have a caller. And this is the first thing I want to talk to you about is if you're writing some code that's going to like live and it's not trivial or throwaway code, one of the very first things that I do is I refactor main into like a very small function, and I immediately create like a new main function or like a run function. And here's what I'm talking about. Let's rename this to run and have run return to error. And now, and put return nil at the bottom. Now I have a nice function that returns an error, and my error handling simplifies. No longer am I panicking and preventing any callers from handling my error, or no longer am I printing the error and then doing os exit 1 everywhere. This error handling has become much simpler. I'm just returning the error and letting my caller handle it. Well, who's my caller? Well, I still need a main function, right? Because every Go program requires a main function to execute. And now, instead of doing all of that logic in main, I can call this run function, and it will return an error. And if that error is not equal nil, then I can actually handle it. So I can do the printing that I want to do, and I can do the OS exiting that I want to do. And now, instead of doing this in every if error.equals nil block, I've extracted it down to a function. I only have to do it one place, here in main. And then now anything that runs into an error in this run function just has to return it up the caller. So this is the pattern I follow when I'm writing Go programs that are like, non-trivial or things that are going to stick around, because it makes error handling so much easier off the bat. And when I refactor this code, let's say like this code is going to go into another function like func, create file that takes a name or something and returns an error. Well, I can just literally lift this code, right? I can just say, give me this, put it here, and it works, right? Nothing has to be done. Like this return error matches the signature, blah, blah, blah. Everything's happy here. I mean, granted, I probably should have returned a file here, whatever. But you get what I'm saying. If I put a panic in here or a print and an OS exit, I wouldn't be able to easily move and refactor my code. So right off the rip, what I end up doing is a pattern like this. Keep main very short and very small and create that new main or that run function to hold the logic that you're going to do. Let's talk about that deferred error that we ignored earlier. So down here we have defer f close, and this f close actually returns an error, but we're not doing anything to handle this. So the way defers work is they execute after the function that they're within returns. So when the run function returns, the defer will actually execute, and it'll run f.close, and it'll ignore this error essentially because we're not doing anything with it. So how can we actually like handle this error or at least see it or whatever? Well, we do that with what's called named returns. So I'll give this error return value here a name called error. And you'll see if I jump to definition, my returns are now using this named error. So basically, every time I like write to this error variable, it's writing to this variable name right here up top, this named return. So regardless of if I return here or if I return down here, they're all writing to this same error value. So now I get the opportunity to do that as well myself. And I can do that with an anonymous function. So I can put my f.close in this anonymous function, and I can do something like this. I can do like close error equal f.close if close error does not equal nil, then set error to close error. So I can do this. This looks good on paper, this looks fine, but the problem here is this overwrites error entirely. So if I got down here to write string and I return a non-nil error, then my defer function runs and it also returns a non-nil error. I overwrite that write string error with my close error. And that's not good because I've just shadowed this error. Instead, what you'd really want to do is you would want to do something like this. Error equals format.errorf. And you'd want to put both of those errors in here. And we'll see how to do this much better later, but you can put both the original error and the close error in here. And now what you're doing is you're not losing this write string error anymore. You're just putting both errors next to each other so that you can kind of add that context. Now, we'll show a better way to do this later on that's applicable inside defer, outside defer, wherever. But I just wanted to show you that these deferred errors, they're not lost. You can do things with them and make your program more resilient. And honestly, that matters sometimes because even though you might be saying, hey, Matt, like f.close is pretty stable, it's not going to fail. And even if it did fail, my kernel is going to figure it out for me, right? Like, sure, probably that's going to happen. But there's other errors that you like call defer with that you might want to handle, right? Like closing connections or starting and stopping servers or blah, 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 that you just want to be able to have that option. And here's a way for you to have that option. Let's talk about how to check the different errors that can be returned, right? Because we have these if error does not equal nil blocks, and that's great. We're checking if we got a non-nil error, but how can we check like what exactly that error is, right? There's different kinds of errors out there that signify different things. Some can be fatal, some can be ignored, blah, blah, blah. And we need to know how to like check for those, right? How can we check? Well, the f.write string here returns the number of bytes written and an error. But what if I didn't write all the bytes that I wanted to write? For example, I want to write hello world. And what if I just wrote hello? Like that's a problem, right? Well, yeah, it is. And this write.string has the ability to tell you when it does like a short write or a partial write. And it does that using the io.error short write. So this io.error.shortWrite is an error in the IO package that says, hey, you received a short write. You should probably like figure this out. So how do I assert that this error was the one that I received? Well, it's actually, the syntax is pretty simple. I can do if error equals IO short write, and then in here, I can do whatever I want. I could ignore it. I could return, I could return nil or error. I could do whatever I want in here. So this is how you assert. And you're just basically saying if the error I received is equal to the short write error, go do what you got to do. This is great. But this is the old syntax, right? So I'll put like old syntax here. If you wanted to do this in the newer syntax that Go recommends you using, you would do errors.is error IO error short write. And now this is the new syntax. And in here, you can do whatever you want. You can say, oh, if I get a short write error, we're gonna return nil, or we're gonna just ignore this, or we're just gonna like silently fall through, or whatever you want to do. You're The world is kind of your oyster with here, and you can do whatever you want. But I know you probably have a question here, or at least if you're a keen viewer and you're paying attention, you probably have a question. You're probably like, wait, Matt, how did you even know that this error short right was a valid kind of error that can be returned from this right string call? Honestly, I have bad news for you. I didn't. I didn't. There's no easy way for me to tell, like looking at the function signature, what right string can return. In fact, even if you look at the documentation, look, this is just the documentation for this. Right string is like right, but it writes the contents of a string instead of a slice. Okay, so if it's like right, that means it calls right. So let me go look at the documentation for right. And you can see, oh, it returns a number of bytes written or an error. And it's like, there's nowhere here in the docs that tell me that this short right error or whatever is a valid error that can return. I had to actually look at the source code, which kind of sucks, right? Like it's kind of is annoying that there's no real good way in Go to say from all the way up here at the function call level to say, oh, what are the valid like array of errors, right? The valid different errors that could be returned here. There's no way to enumerate that. You kind of have to just read the docs, read the source code, and follow your call path down to see what different errors can be returned, what they mean, and see if you want to handle them. And that's the unfortunate truth. I mean, there will be some of those errors that you want to handle. Some very popular ones off the top of my head are like IOEOF, which stands for like end of file, which means that you've reached the end of whatever file that you were reading. Or there's error SQL no rows to signify that the SQL query that you ran returned no rows. And there's all these different kinds of errors there that you want to use in different ways. But it's not easy to find out what functions return which. So if you care about those things and you want to assert on the different errors, you're going to have to read the docs, read the source code, and figure that out. In the future of this video, I'll show you how to create your own custom errors and assert on them. But for now, here's what you got. Let's see how we can return errors so the callers can handle them in different ways. So this code is different. I have a couple variables up top here, two variables, user banned, user invalid, and these are set to new errors. If you call errors.new and you give it some string, you can get an error back with that string. This main function is what we've kind of seen before. It calls the run function and logs errors and exits one. And then the run function, all it does is it creates a user, it calls create user, and then it will check the different errors that can be returned from create user. It checks if the error was a user invalid, then it'll print this. If the user was banned, it'll print this, and otherwise it'll print this. And this is just showing you like the only difference here is these prefixes just to show you which case was hit. At the end, it'll just print out the user and return nil. The create user function takes a user by name. If the name is empty, it returns user invalid. It then tries to save the user in the database. And if it can't, it'll return that error up the call stack. And in the save user in database function, it also takes a user by name. If that name happens to be Eve, we'll just return error user ban. In all other cases, we'll create the user. All right, so this is just simple trivial code to show you like a typical kind of, 3-level call stack, so to speak. Now, what's going on here? I actually want to run this code a little bit and show you what's happening. So let me open up my thing and run this. If I run this with the user Alice, I'll get created user Alice. Great. Now, if I run this with an empty username, so something like this, and I ran this again, I'll get invalid, failed creating user, user is invalid. So clearly I hit this case here. I hit this error user invalid case because when I called create user down here, this returned error user invalid and I asserted on it. What about the banned? What if I did this? What if I actually created the user Eve instead? Now we know Eve's a banned user, so we should get error user banned. So let's do that again. But I didn't get the banned prefix here, right? I didn't fall into this case. I only went into this case. And we'll see how to fix that in the later video. But what I want to show you is that you can return these errors up the call stack. And usually the way you do this is a couple ways. One, you can return errors directly using, these variables that I have here, right? This is an error variable that I created. Or alternatively, you could have done this, return errors dot new, and I can do like this. And instead of, I'll just say rip, I could have done this. I didn't have to use a variable for this. I could have called errors.new directly. The problem with that though is if I wanted to like match against this, I'd have to do case errors dot is error errors dot new and then rip. And I have to do this everywhere I want to match on. It's not a named variable. I actually have to write out errors.new if I wanted to like assert on this. And if I change this error text to like, rip v2, well, now this assertion breaks. So if you're going to return things like errors.new and you care about asserting on that error, just don't even do that. And instead create yourself an error variable like this and use that, because now you have a name at least to assert with. But what about this user band? So this user band, we're using format errorf to return this up to the caller, right? So you can see that way down here. We're saying, hey, format errorf, I would like you to take the error that you received from calling save user in database. I would like you to tack it onto the end and add some more context here saying like what happened. We failed saving user. Here's the original message. So format errorf is a very, very powerful function. It allows you to add more context to an error. It allows you to add more information to an error to make it more descriptive. But you'll notice that even though we did add the error in format errorf, we couldn't use this error user band assertion. And that's one of the things. And I'll show you that why in a second. But when you're returning errors, all I wanted to show you was you can use errors.new. You can create a named error like this with a variable. You can use format errorf to return errors. There's all these different ways to return errors in Go. All of them have their pros and cons, and we'll see them more and more as we go through this video. So let's talk about how we can fix that user band error, right? That case. We weren't falling into this case before. When I tried to run this before and I ran, returning errors, it said failed creating user Eve, user has been. I see that but I didn't actually fall into this case here, right? I didn't actually get this band prefix here. Like, why not? Well, it was the way that I was calling format errorf. Previously, I was calling format errorf with a %v. And let me diff this for you for a second. Previously, I was calling format errorf and I was giving it the %v verb for my error. I updated that to use %w. Well, what's the difference? That's the only difference between these code, right? So what's the difference here? Well, the difference is if I look at format errorf, the documentation for it real quick, you'll see that, let me go a little bit down. You'll see that format errorf will actually add errors, but it'll use different verbs. And one verb is the %w, which tells format errorf, hey, I want you to actually wrap the error. Don't just give me the error string like %v did. Actually wrap the error so that the included error kind is there and can be asserted upon. So without this wrap, so let's go all the way down to the end of this file. What's happening? The save user in database is returning, if Eve is passed here, we're going to return error user band. Great. Then up the call stack, when I call save user in database, I'm calling format errorf. Now, instead of that %v, I have %w. So that error user's band error is now wrapped inside this new error that's being created, and I'm returning that up the call stack back to the run function. Now the run function can look at this whole error that was returned, and it'll do what's called error unwrapping. This error will actually look at the error, and it'll follow unwrap all the way through and check if any of the wrapped methods contain the error that you're looking for. This is kind of a confusing thing in Go, but very powerful. So if you don't wrap errors, you don't give the callers the ability to assert on them, right? This is very evident here, right? Because I have run calling create user calling save user in database, and save user in database is returning a specific error, but create user was not wrapping the error correctly. So when it passed it back up to run was like, I don't know what error user band is. Sorry, I see the text, but I don't know that that kind of error is there. So this is why error wrapping is so important. And you should probably get into the habit of using this, right? You should do, if you're ever returning an error back up the caller, you should wrap it so that way the caller has all of the wrapped errors at their disposal. If they want to reach for an error way deep down there in the wrap chain, they can, which is the case here, right? I want to reach for that user banned error way deep down there, and I want to just assert on it. Otherwise, if you don't wrap the errors, you're relinquishing all of that capability from your caller, and you're not giving them the choice to do it. So I'll go back to the diff real quick because I thought the diff was pretty cool. This is literally the only difference in the code of how one is not wrapping the error, so it's not letting the callers, see what the actual underlying error kinds are, and one is wrapping the errors and letting the caller decide. This is the difference between code that's going to drive you crazy and code that's going to make your life simple. So TLDR, use %W when you're returning errors with format errorf, and keep that wrapped errors in there and give the caller the ability to decide. Let's look at how you can join errors now. So this is something that actually this bothers me a little bit. I'm not gonna lie to you. This one is kind of near and dear to my heart. Let's look at this code. I'm pretty much just calling validate credentials, and validate credentials takes a username and a password. And if the username is blank, it'll return an error. And if the password is blank, it'll return an error. This code frustrates me. It is correct, but it frustrates me. Let me show you why. So if I actually like run this in 05, yeah. If I run this with empty username, empty password, I'll just get one error. Username must be non-empty, and it'll exit and blah, blah, blah. And let's say I updated this, right? Like let's put a username in here. Let's put like Matthew. Great. Now I have a username in there. Now I'm gonna run this again. Still not working. Password now must be non-empty. So I'll go in here and put like, ABC123. So I have a password now. Great. Now if I run it, great. Everything's great. Exit 0. Everyone's happy. Frustrating code, because this code actually knew that both of these were invalid, right? It knew that, hey, username being empty and password being empty, both of those are a problem. It could have told us all of that at once rather than making me do another round trip and another round trip and correcting things as I go along. This is where error joining comes in. Error joining allows you to take these errors, kind of bundle them up as like multiple errors in one, and send them all back to the caller. Let's see how to do that. Well, to do join errors, you need a new error. So I need var join error. So this is gonna hold my joined error, and then here I can do errors.join, and then do the joined error, and then errors.new username. I could have copied this, but username must be non-empty. So now get rid of that, and I'll set that equal to join error. It has a similar syntax to like the append function in Go. So here's me joining the error together, and I'll do that again for the password. And I'll do errors instead of username, we'll do password. Great. Now I've joined this error. And if I get to the end and join error is not equal to nil, then we can return join error. This code now, if username is empty and password is empty, we'll get both of them. Boom. Username must be non-empty, password must be non-empty. I've joined all those errors together, and now I can send it all back to the caller. This is much less frustrating code because this allows me to kind of do things in quick succession that can all error, but like all of them have to be kind of a problem, or some of them have to be a problem, but you evaluate that. It's very useful for like parsing configuration or parsing like information that's required from the user, where you don't want to like bail on the first error. You kind of want to bail when you get to like a point where you're like, oh, here's the 7 things you did wrong, fix them. Joining errors is very powerful. If you look at the documentation for it, you can see that it joins errors and it wraps them as well. So if you had different different kinds of errors, you can use join error to wrap them all up. And I could have had like an invalid username error, an invalid password error, wrap them all up with join error, send them all back to the caller, and the caller can assert on any one of them. This is new in, I think, Go 122. I don't remember the exact version of Go it came out. I think it's that. But this is new in a recent version of Go. Super powerful, something that I use pretty often when I have these like blocks of code that I don't just want to bail out on the first error. Let's end this video talking about custom errors. In Go, errors are an interface. So if I look at the documentation here, Error is an interface with one method that takes nothing and returns a string, right? One method called error. Any type that has this method called error with that takes nothing and returns a string implements the error interface. So if you wanted to create your own custom errors, all you have to do is implement the error interface. So here I created a custom error structure that has a message field and an isFatal field. And then I implemented the error interface by creating the error method that just returns a message. Great. Now I have a custom error that I can use. So anywhere that I need to return an error or otherwise use an error, I can use a pointer to a custom error type instead, because that implements the error interface. So way down at the bottom here, real quick, I have this do work function that takes a number and returns an error. And if the number is negative, it'll return a custom error with just a message inside. If the number is positive, it'll return a custom error with the isFatal set to true, also with a different message. And otherwise, if the number is 0, we'll just return nil because that's all good. And up here in the run function, I have this do work where I'm calling do work, and I'm then asserting on whether or not the error that is returned is a custom error. So in this case, the syntax for that is you need to create a pointer to the custom error, then pass that into errors.as. We haven't seen errors.as before, but what it does is errors.as will look at the error that's there, unwrap it until it finds an error that is the target, and it'll set the target to that error. So the TLDR is it's going to look at this error chain for a custom error. If it finds a custom error, it'll set that custom error variable to the custom error that it found. And that's super powerful because now I have access to that custom error and all the fields that are within. Specifically, I have access to this isFatal field. So I can say, hey, I did receive a custom error back, and now the isFatal field was set to true, right? This is a fatal custom error. Let me return an error and stop the execution because something happened that's bad. Otherwise, if I didn't receive that isFatal error, I can just print it out and continue execution because it wasn't fatal. I can just keep going about my business. This is the power of these custom errors that you can create, is you can add whatever fields you need into the custom error structure and use them for various purposes, right? You can use them for conditionals like I am here. You can implement other interfaces like Marshall JSON and print your custom errors in different ways. Super, super powerful. Let's see this code in action real quick. So I'll just run this code and you'll see nothing printed because I passed the do work function 0. If I pass it a -1 instead, then you'll see that I logged non-fatal error and I still exited it with a 0 because even though I did receive an error, it was a non-fatal error. So I just logged it and I didn't return an error. But if I pass that positive number instead, well, now I received a fatal error. So I'm going to return it and exit 1. So you can see here the power of this custom error logic. And generally speaking, you want to use a structure when you're implementing errors. That way you can implement the error interface and add different fields that you can use. You could technically have done like something like this, like foo error string, and did one of these and created a new type. I don't really recommend this. It's not super powerful, even though Go does allow you to put methods on types like this, primitive types. I would recommend using a struct, in my opinion. That's the better way to do it. And if you looked at like the errors package from the Go standard library, so like if I showed you real quick, errors.new, if I showed you this and I go here, even the Go standard library, it implements its own error interface with a structure rather than with like some primitive type. So if I were you, if I'm going to implement custom errors like this, I would use a structure and put your fields in there and do the thing. And one thing I didn't really show you is, like I showed you but I didn't talk about, is look how nice the return is here. I'm returning an error, but my return is just, hey, return a pointer to a custom error with this stuff. Like, this is the power of interfaces in Go, where custom error implements the error interface, and this is what my returns look like. This is super, super smooth and super clear. And honestly, it's pretty greppable, right? Like if I were looking at this code base from the outside and I want to say, hey, like, where do I return custom errors? I can just like grep around for custom error and find all these nice places of where I return them. So custom errors are something you shouldn't be afraid of. You can use them. Here's how to assert against them. Here's how to use them. And they're pretty fun. So give it a go and, see what you like. Thanks for watching this video. I hope you enjoyed it. I hope you learned something. If you did and you really liked it, please like, subscribe, the whole deal. Follow me on the socials. Reach out to me if you have questions. If you didn't like it and you want to hide behind the thumbs down button, go for that. Go ahead. Yeah, just a plain boring. But if you really didn't like it, I'd be happy to take feedback if you have something constructive to say, right? You can't just be like, video sucks. Oh no. But yeah, I like I said in many videos before, I do this just to help people. So I'm not here to sell you something or make money. I'm here with my doggy. Look at pups. I'm here with pups. Like, come on. What? Who? Bye.